To CalcPath Geometry, we're looking at the summary of your quadrilaterals exploration. So by now you should have already completed and compared and then checked your answers to all of your calculations about the sides of the parallelogram, the slopes of the four sides, the distances of the four sides, and then the midpoints of the diagonals, slopes, and distances as well. So you should be really proficient now at using formulas for midpoint, distance, and slope, especially when it came to the diagonals. For the sides, you might have just counted or used Pythagorean's theorem right here. Conclusions about the parallelogram. Well, the definition is actually in the name of the word for a parallelogram. For a parallelogram, the definition is that it is a quadrilateral with two sets of parallel sides. Those parallel sides are obviously the ones that are opposite of each other. If they were adjacent, then they would touch each other and be intersecting, so they couldn't be parallel. So there are two sets of parallel sides. That is the definition of a parallelogram. Two sets of parallel sides. Well, that actually gives us some triangles in here. I can look at the rightmost and leftmost. We have a bunch of different triangles in here. We could actually prove some of these triangles are congruent using angles and sides. We'd have to know some more information first, though. Properties of the sides. From your distances, you should have seen that there are two sets of sides that are congruent. There are opposites. Opposite sides are also congruent. Yes, they're parallel, but that's the definition. It's also a property, but it's more the definition for this particular quadrilateral. Now with the angles, you may not have made an observation about this, but obviously if you have parallel lines, then that means these that make the C are supplementary. Those are same side interior angles. So these two are supplementary, and these two, which are also formed by parallel lines, are supplementary. Every consecutive means in order. These two are supplementary, these two are supplementary. So every consecutive pair are supplementary, meaning that they add to 180. Also, the opposite sides will be congruent. These opposite angles, I mean. This angle will be congruent to this one will be congruent to this one. We could prove that, we may be proving that later. So with respect to our angles, we have opposite angles congruent and consecutive angles are supplementary. That doesn't mean that they're both 90, because being 90 would mean that they were also congruent, and they're not. They're different. This is obtuse, this is acute. But they're supplementary in that when you add them together, they'll add to 180, making that same side interior angle pair with the parallel lines. The diagonals of a parallelogram, some people were putting down that they are congruent. They are not. This one is definitely longer than this one. This one is the shorter one. So they're not congruent. They are not perpendicular. There's an obtuse angle here and an acute angle here, but they do bisect each other. So the diagonals for everything that can be considered a parallelogram, the diagonals bisect each other. So that's our parallelogram. When we look at the rhombus, the definition of a rhombus is actually a quadrilateral with four congruent sides. There's other things that are true about a rhombus, but its definition is that it is a quadrilateral with four congruent sides. Yes, those sides are congruent, but like the parallelogram, it has two sets of parallel sides, or opposite sides parallel. And it also has all four sides congruent, but that's already part of its definition. Its angles, again, we have opposite angles congruent and consecutive angles supplementary. We can see the letter C, the same side interior angles. When we pair any of those with those parallel lines. But again, the definition, I'm going to mark just the definition, is that all sides are congruent. So with our angles, once again, we have opposite angles are congruent, and consecutive angles are supplementary, meaning that if this was 70 degrees, this would have to be 110, because they'd have to be supplementary, adding to 180 to be true with those lines being parallel. The diagonals of a rhombus do bisect each other just like the parallelogram, but they do something more. No, they're not the same length. As you saw, this one AC was longer than BD, but they are perpendicular. If you look at the slopes of those lines, this was a slope of 1, this is a slope of -1. Those are opposites and reciprocals. It's one of those numbers that you don't see the reciprocal part, but it is, because 1/1's reciprocal is 1/1, and then we change the sign. So that means that those are all right angles. It means we have 4 right triangles, and we know that these have been bisected, and we have that, so we could prove those triangles are congruent if we needed to. But, so sometimes we think about these shapes in terms of triangles. Right now, we're just trying to write down the facts that should be observed from your calculations. Our next shape was the rectangle, and yes, you learned about this in kindergarten, so you knew all about the rectangle already, but its definition is actually a quadrilateral with 4 right angles. A quadrilateral with 4 right angles. Well, it's true that its opposite sides are congruent. That's one of its properties, and that its opposite sides are parallel, or 2 sets of parallel sides. So a rectangle is a parallelogram. It meets the definition of one, having parallel sides. This also right here, it says definition of parallelogram. It should say definition of rectangle. We'll need to fix that also for the rhombus. That was definition of rhombus. The angles of a rectangle, well, duh, it's in the definition. See the definition, because they're all right angles, which means that they are all sets of angles, or all pairs of angles are supplementary, including the opposite ones. Yes, they're congruent, they're supplementary and congruent, because they're all 90 degrees. So they're all congruent because they're each 90 degrees, and any 2 that you take are supplementary, any 2, even the opposite ones. For the diagonals of a rectangle, they are not perpendicular, because we can see there's an obtuse angle, there's an acute angle. But they are the same length, and they do bisect each other, just like the parallelogram, because this is one of the parallelograms. It's a little more specific. They bisect each other, and they are congruent. When you did your distance calculations for AD and BC, you should have gotten the square root of 74 for each of those lengths. We next move on to our square, and we're going to want to make sure that we change it to definition of square. And a square is a quadrilateral. It's also a parallelogram because we have 2 sets of parallel sides, as you saw in your calculations. But it is a quadrilateral with 2 things. It has to have 4 congruent sides, just like the rhombus, and it has to have this as well, 4 right angles. So that means that a square meets the definition of a rectangle because it has 4 right angles, and a square meets the definition of a rhombus because it has 4 congruent sides, just like the rhombus. And it also meets the definition of a parallelogram since it has 2 sets of parallel sides. The sides, yes, we already know they're congruent, but we also have opposite sides parallel. For our angles, we have all angles are supplementary, and all angle pairs are supplementary and congruent. So it doesn't have to be these to be supplementary. They don't have to make same side interior. They do for the parallelogram and for the rhombus. But for the rectangle and square, because they're congruent and 90 degrees. Every pair you could pick is congruent and supplementary. The diagonals of a square are unique. They have much more going on. Just like the parallelogram, they do bisect each other. Just like the rectangle, they are congruent. And just like the rhombus, they are perpendicular. And a square meets the definitions of all three of those shapes: parallelogram, rhombus, and rectangle. So of course its diagonals will also have those properties. Hopefully you were able to finish up the kite before we had our meeting, but we're going to look real quickly at the definition of a kite. The definition of a kite is a quadrilateral with two sets of consecutive congruent sides. So it does not mean that opposite sides are congruent. Nope. These two that touch, they're adjacent. So this one's consecutive as I go around. These two touch, they're consecutive, they are congruent. And then as I go, this one's different, but the very next one that's consecutive is also congruent to it. Or the next one in order. The next consecutive one is congruent to this. So we have two sets of consecutive sides. That is a kite. Yes, the sides are going to be, we need to see definition. They are not parallel. I know this one did make a 90-degree angle for this kite, but that doesn't always have to happen, so I'm not going to put that in. I'm just going to put C definition. There's nothing more to the sides. We don't have parallel. They're not always perpendicular depending on the kite. They could be, but they don't have to be. The angles are a little unique. This one and this one, there are the ones touched by the shorter diagonal are congruent. The ones that touch the shorter diagonal are congruent. The ones that touch the longer diagonal, if you look at this, we've got this triangle and this triangle are congruent, so these angles are going to be congruent. These are not congruent. This is different from this. This is bigger than this one. This one's different from this, but together they add to the same amount. This whole of angle A and the whole of angle D are congruent. Those are the ones that are touching the short diagonal. But when I look at B and C, this one's definitely smaller than this one. But this angle right here is congruent to the angle. It's really been bisected by the diagonal. And this one, which notice I put 3 arc marks, this only has 2. This is 3. So this and this are not the same. You can even see that. This triangle and this triangle are not the same. But this angle C has been bisected and angle B has been bisected. And it's hard to see that in our calculations. But the ones that touch the long diagonal are bisected. That doesn't mean they're congruent to each other. The two ends of the diagonal aren't congruent to each other, but the angles that are touching the long, like this, the long diagonal touches angle B, it's cut into 2 equal parts. The diagonals do more based on your calculations, though. They do not bisect each other. They are not congruent, but they are perpendicular. The kite has perpendicular diagonals. That means that these are all right triangles. These 2 triangles are congruent. These 2 triangles are congruent. And the very last shape that we looked at in our exploration was the isosceles trapezoid. The definition of an isosceles, well, we're not going to do isosceles, we're just going to do the definition of trapezoid. The definition of a, well, isosceles trapezoid, we might as well do that too. Isosceles trapezoid is a quadrilateral with only one pair of parallel sides, and the non-parallel are congruent. That's what makes it isosceles. So the sides, again, the non-parallel sides are congruent for an isosceles trapezoid only. If it's not an isosceles trapezoid, like if it's like this, then they're not congruent. Those are 2 different things. But if it is an isosceles trapezoid, then those are supposed to be congruent. We have one opposite sides parallel, the other opposite sides are congruent. For our angles with the parallel lines, these are called base angles. We have the top base angles, the bottom base angles. We will have two sets of supplementary angles, the ones formed with parallel lines. If it's not with the parallel lines, like if you look carefully at the picture, A and B, these two lines are not parallel. This is an obtuse angle and this is an obtuse angle. They're going to add to more than 180. Those lines will never be parallel. So only the ones formed with the parallel lines, in this case B and D and A and C, you can even look for the same side interior angles, the letter C, those ones are supplementary. Now when it's an obtuse triangle, or when it's an isosceles triangle, the ones that are not supplementary are congruent. It's called base angles congruent. So these base angles that sit on this base are the same measure. And then if you flipped it upside down and put it on this base, these angles would be congruent. So the angles, the non-supplementary, are congruent. They're called the base angles. For our diagonals do not bisect each other, but our diagonals are congruent, and their pieces are congruent too. We didn't see that from our calculation, but if we actually knew what this ordered pair was, we could see that this and this are the same length, and this are the same length, and the whole thing add up to the same length. These two are not the same though, because that is not the midpoint. So this is the little conclusions box for our isosceles trapezoid. Some of this, the fact that the diagonals are congruent, we were able to get from our calculations. The fact that two of the sets of sides are congruent, the non-parallel ones, we were able to get from our calculations as well. We're going to transfer these to our flipper in the next video clip.